Yes, sir.
Okay, thank you. Okay, let's start. So first of all, I promise that it will be a very short class, not more than half an hour maximum half an hour. So please be attentive. Um, just a minute, sorry. Hello, hello. Yeah, can you hear me? Hello.
Yes, sir, we can hear.
Yeah, okay. Okay, so let's start. Yeah. So we are talking about the search techniques, and we have already discussed about the during the search there are two main component. One is the G value, another one is the H value. I mean, for example, we start from the initial state, and we were looking for the goal, uh, and now on the way, already some of the nodes are in the waiting state. You can see there are, for example, this is node number A, B, C, and D, and both for the informed or intelligent search and non-informed or uninformed or non-AI search, there are two main things. One is the G. I mean, we can calculate the G of A. So we have to calculate the G of A. And there is another option. We can calculate the G of H. Sorry, I mean G of A and H of A. Similarly, we can calculate the H of B and G of B. So in every node, there are two components. There is H and G. H and G. So based on this H value or G value, we can think about which one should be explored next. So the priority of the nodes, I mean, these A, B, C, and D, these are the nodes which are waiting to be expanded. Now, which one we should pick? Right now, there is only 4 nodes that are in the waiting state. But in reality, there are thousands of, even millions of nodes are there those are in the waiting states. And some of the states, I mean, as you know, these are all state. And alternatively, we sometimes say the node. So node and the states are all the same thing. So these states or these nodes are kept in the waiting. That means those are in the memory. So the more nodes are in the memory, that means the more space it's actually occupying. So we need to reduce the waiting states, and that is also very important. And at the same time, we should know which one is preferable compared to the other one. So in the non-AI search, that means uninformed search, we are actually concerned about the G value. So what does it mean by the G value? That we have explained in the last class. So G means the actual cost of that node from the initial state. That means, for example, if I talk about what is the G value of A, that means from the initial state, the total path cost, the actual path cost of the node A from the initial state is called the G of A. And now, what is the H of A? The H of A is the estimated cheapest cost from the node A to the goal node. So two important things. One is here is the actual, and this estimation is, we call it estimated. So we have discussed a lot about these two things, actual cost and estimated cost. So basically G is the actual cost, H is the estimated cost. And G is the cost from initial state to that state, the actual cost, and H is the estimated cost from that state to the goal state. So now we have explained the what part. These are actually the what, means what is H. And in the last class, we have also explained why. Why should we use H? That means, um, in fact, I mean, it's easily understandable that among the nodes which are waiting, if we pick the H, that means we are actually picking the node which is more close to the goal. So inherently, we can easily understand that among the waiting nodes, if we pick the node which is more close to the goal, then definitely we should reach the goal very early compared to the other nodes. So the why part, I mean, why should we use H? That is clearly distinguishable, that is clearly understandable. So what and why, even though I will explain in more detail why should we use H, but for now, I think this is good enough. Because previously we have no idea. Previously we have no idea about H. So now we have understand what is H. And as I said, I mean, since we are picking the node that is more close to the goal, definitely, I mean, we are going closer and closer to the goal. And very soon we'll reach the goal. So it makes sense, right? So what is H and why is H? These two things are, I hope it is clear. But we'll drill down to these H things in detail in the upcoming classes. I mean, what are the detailed component of the H? What are the different type of H? So these are also important. Even in the last class, we also came to know what are the different type of H. Means actual. Sorry, I mean how we can calculate the H. How to calculate, right? How to calculate. So how to calculate the H? We only know the goal, but we don't know the path to reach the goal. Then how should we calculate the H? So in that respect, we already explained in the last class. The main idea is relaxation. Relax. I mean, relax. So how could we do that? Given a problem P, the first thing we should do, we should relax the problem. So we should find a relaxed version of the problem. And then we should find the cost, means the, I mean, we should solve the problem. The relaxed version of the problem, we should solve it. So we should solve uh, the relaxed version of the problem. And the value it returns is basically the H value. So the value, so from here, the value we receive, and that is basically the H value of the P problem. So it looks difficult, but it's really easy. For example, you can see the map from Edinburgh to Saarbrücken. We have to go from Edinburgh to Saarbrücken. So this is the problem. We have to go from Edinburgh to Saarbrücken. So first thing, we have to relax the problem. How we can relax the problem? For example, here is the relaxed version. There is no map. Okay. So as you can see from the problem, we relax it to we find a relaxed version. And now we have to solve the problem. Since there is no map, we don't need to think about very internal details. Means what are the paths, what are the blockages, what are the obstacles, etc. We don't know. We don't need to think anything of it. And now we have to solve the problem. Now we have to. The third part is we have to solve the problem. We have to solve the relaxed version of the problem. So how we can solve it? Very simple. Just a straight line. Since we know the XY location of the Edinburgh, and also we know the XY location of the Saarbrücken, we can just a straight line, means we can perform a straight line distance, that is the Euclidean distance. And this value, say 1013, so this value is actually the H value. That means H of Edinburgh is equal to 1013. That's it. So that is the estimated cost. Definitely this 1013 kilometer, we cannot reach the goal, but well, I mean, this will at least give you an intuition or an idea how far Edinburgh is from the Saarbrücken, and that will help you, or that will guide you in doing search, the actual search, and that is very important. So the summary idea is relax is very important in AI to solve the problem intelligently, even in our real life. The very important thing is we have to relax the problem. Once you relax the problem, you will get some idea. And this is not only true for this current pathfinding problem. We have also in the last class we have also seen some other examples. For example, here is the 8 puzzle problem. It might looks different, but the common idea is same. I mean, the same idea that we have seen before for the pathfinding problem can also be applied into this 16 puzzle problem also. So again, this is the initial state. This is the goal state, for example. And now how we can find an estimation from I to G. I mean, from this node to this node, or this state to that state. So again, we have to relax. The first thing, we have to relax the problem. So how we can relax the problem? Just there could be many ways, but one of the way is just remove some of the tiles. Okay, so there is only now 8 tiles, 1 to 7, and the blank. So this is the blank tiles. Okay, now it's easy. This is a relaxed version. Now solve the problem and find the value. I mean the value of the solution, path cost, and that solution will give you the heuristic value of the current state. So this the relaxation can be done in many different ways. So this is one way. I mean, we can relax also in the other way. For example, here we have seen in the last class that how we relax. I mean, since the constraint is if you want to move the tiles from X to Y, there are 2 constraints that they should be neighbor and Y should be blank. Yeah, right. So among these 2 constraints, since this is the actual problem, we have to follow these 2 constraints. So it's very easy. We can remove one constraint or another constraint or both constraints, and we'll find different heuristics value. So we can remove one, or we can remove 2, or even we can remove 1 and 2 both. So there are 3 relaxed versions of this problem, and every relaxation will give you an estimation, and that estimation is actually the heuristic value, and that you have also seen in the last class. So well, I can give you another example. For example, the grid pathfinding grid problem. So say Okay. So say this is a grid, and this black, you can see the black tiles or the black grids. Those are actually the obstacles. That means you cannot go through that black uh, grid. Those are the obstacles actually. So now, for example, this is our initial state. As you can see, this is our initial state. And now this is our goal state. So you know the goal, you know the initial state. And now, who can say what should be the, I mean, how we can calculate the heuristics of the initial state? I mean, how can we relax? So idea is saying you are given a problem. The problem is to find the goal node or the goal grid or the goal location. Go to the goal location. The only constraint is you cannot go through the black tiles or the black obstacles, and also you can go up, down, left, right. So these are the constraints. You have to go up, down, left, right. So there are basically, you can say there are three constraints. One, you cannot pass through the block spots. I mean, these blocked spots or grids, and you can go up or down or left or right. So these are the two constraints basically. Well, you can divide the second constraint into four different subparts, but it's okay. So now who can say, I mean, how can we relax the problem? Or in short, what should be the heuristic value of the initial state? I mean, you are right now at 1 location, and you have to go to 515 location. The location of the G is 515. As you can see, this is row number 5, column number 15 is the goal node, and the initial location is 1. So how can we go from 1 to 515? What could be the estimation? Remember, I mean, we have no idea about the internal blockage. I mean, once we dive into the path. I mean, once we go deeper, and then we'll see some of the block spots are there. I mean, we cannot pass through those things. So, well, I mean, what could be our estimation? I mean, what could be the estimated value?
At first, we can think that there is no block.
Excellent, excellent. So if there is no block, excellent. Now there is no block, you can go up, down, left, right, and your start location is 1 and your goal location is 550. There is no block inside. Now what should be the value? I mean, how we can now solve the problem? So the problem is you are in the location 1 and you have to go to location 550, 515, and there is no block. And now solve the problem. Now what is the solution of this problem? There is no blockage. Remember, there is no blockage as you relax the problem. So there is no blockage inside. So you have to go from 1 to 515. But you have to go in this way, up, down, left, right. You cannot go through diagonally. Now, what will be the result of this problem? If you solve the problem, what is the value? How we can calculate the value?
So difference between the x values plus difference between the y values.
Uh, yes, the absolute value. Excellent. So from this xy, x1, y1, and if this is x2, y2, so the things are very simple. X1 minus x2, the absolute value, plus y1 minus y2 by absolute value. I mean, again, the Manhattan distance. So 1 minus 5, its absolute value, plus 1 minus 15, its absolute value. So is equal to, the total value is 1 plus 14, right? Sorry, 4 plus 14 is equal to 18. And now you can see this 18 is here. Can you see the value 18? Is it clear now?
Yeah.
Yeah. So that is exactly the same idea, right? I mean, say for example, you are right now here in the location 39 location, and you have three neighbors. One is this, one is this, and one is this. One is at the up, one is down, and one is at the left. Now, if you find the similar way, if you do the calculation, then you can see this is easily understandable in which way you should follow. So the upper grid, I mean, the upper grid has the heuristic value 9. Sir, how it is 9? It's a Manhattan distance. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a Manhattan distance. Similarly, the 7, why this is 7? 1, 2, 3, 4, 5, 6, 7. And what about the 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we can see among these three children, which one has the smaller h value? 7, right? So we should not explore these two. We should explore this one. I mean, you can easily understand that this is actually guiding us towards the goal. So it's not um, pushing us into the wrong direction. So we are guided by the heuristic value. So similarly, once you reach into this location 7, then you can think about again new children. Who are the new children? This one is a new children, another new children, and now which are in the waiting state. You can see. So once this is explored, this is explored. Now, say for example, this row 4 will be in the waiting state. So 9966. So among these 9966, which all are the H values of that particular position. So among these, definitely 6 is the smaller than the 9, so we should follow the 6. And we should explore this one. And this way, if you follow, now you can see you can easily reach very quickly rather than exploring all these nodes. But the breadth first search or the depth first search could do the wrong decision. This is actually guiding us. But remember, of some of you might be confused, sir. I mean, sometimes there could be a blockage. For example, this one. So the same situation. Say, for example, right now, say you are here and you have two children. One is up, one is down, and definitely will follow the down because that has the less heuristic value. And I will come to this node and then this node and this node because this 10 is still in the waiting. This is in the waiting state because that is a higher value. That 10 is a higher H value. So we should not go to that until we are getting a lower value. So this way we are exploring. It means visiting, and we are almost close to the goal. This is only 2, but unfortunately it's not 0. So we'll follow. But immediate up, it's an increased value, but it's okay. There is no alternative. So you have to go to the up, and then 4. Still 4 is less than 10. So we'll explore 4, but now we are blocked. I mean, there is no path. So we have to come back to the 10 again and then again follow the other direction. I mean, in that case, ultimately we'll reach the goal, but it's actually pushing us to the wrong direction. I mean, since we cannot see the blockage at any stage. But I mean, this is the worst case situation. This is the worst case situation that I mean, worst case situation means the misguided situation. I mean, where we are actually misguided and the very end of the tunnel, we are blocked. And this might happen. This might happen. This is very important. So, I mean, right. I mean, we should know this one. I mean, so from here, the learning is H is the heuristic that actually help us, that actually guide us to reach the goal. But sometimes we might be, I mean, this guide might not be helpful, but in most cases, this is very, very helpful. So that's why there could be a different way of finding the heuristics, and the research is going on. Which heuristic calculation is better than the other? And that's a fantastic research. I mean, people are doing research in this area for any particular problem. If you find a very nice heuristics, I mean, great heuristics, which can lead you to the goal in a very short time, or in a, I mean, that will be a very fantastic research. So as I promised, I will finish in 30 minutes. So we have started at 8:10. Now it's 34. So more for 5 minutes more. Let me give you a complete example for another problem. It's not a grid problem, but let's see the pathfinding problem, and let's see how it helps. Okay, so just the last example. So for example, this is a map of Romania. This is a map of Romania, and we have to, well, our initial state is Arad. You can see the Arad here, and our goal state is Bucharest. So we have to go from Arad to Bucharest. I mean, here every state, I mean, every city is named with a different alphabet. So we can, without uttering the full name, we can just mention the first letter. The first letter of the city, I mean, that's enough. So we have to go from A to B. So A is the Arad, B is the Bucharest. We have to go from A to B, and the internal map details are there. I mean, the actual path cost, for example, from CBU to Fagaras, the actual path cost is 99. Say from, well, I mean, say from Rimichiu to Pitesti, the actual path cost is 97. So here the complete graph is given, but remember, we don't know ahead at the initial state what are the cost of from node to node. That is still unknown, but once you traverse, you will eventually come to know. So now, how can we perform a search with the help of H? And that is basically called the greedy search or greedy best first search. So again, the search by which you prioritize the frontier, means the waiting nodes, based on the H value only. That is called the greedy search. Saying again, the search that follow the H value, I mean, that actually explore the nodes in the waiting states based on the H value only, that search is called the greedy search or greedy best first search, the same thing. So now, sir, how could we calculate the H for every state? Already it's mentioned here. So you can see the H value of Erard is 366, the Zerind is 374, all the values are here. So it's pre-calculated using the straight line distance, So everywhere using the straight line distance, those are calculated. You don't have to calculate, it's already given. Hopefully, if it is there in the final exam or any exam, these values will be given. If not, then you have to calculate using your scale. I mean, using the ruler. But well, I mean, don't no need, that's already given. Okay, now who can say why the value is 0 here? For Bucharest, why this is 0?
It is the goal state.
Exactly. Excellent. So this is the goal state. So from Bucharest, the estimated cost to reach Bucharest, you are at Bucharest. From there, you are estimating to reach the goal, I mean, itself. What should be the estimation? You are already in the goal state and you are searching for the goal state. So from one place to that place, the same place, the estimated cost is 0. Exactly. So that's why this is 0. Excellent. So now, that's it. So now let's explore the search. Okay, let's start with the error. So from error, you can see there are 3 children. You can see there are 3 children. One. So from here there are 1, 2, 3. So that's why there is 1, 2, and 3. And the value 253, 329, and 374, it came from here. So why this is? So you can see the CBU is 253. See, the CBU is 253. So we are just mentioning the heuristic value here, the H value, the H value, the H value. So among these three H value, which one is the cheapest? 253 or 329 or 374? 253, right? And that's why, so already error is visited. So next, that's why we should next visit the CBU. So CBU has 4 children. You can see the CBU has 4 children. 1, 2, 3, sorry, 3 and 4. So from CBU, there are 4 children, but the initial one, error, this is already visited. So we will not re-explore the same node that is already visited. So the remaining 3 children, you can see here, and again, all the H value is there. Now, there are 5 nodes in the waiting state, and all the H values are there. So which one should be explored next? So among these 5 states or nodes, which has the minimum H value? 176, yes or no? So it's 176, 380, 193, 329, 374. So 176 is the minimum age. So that's why the next state should be the next visit should be the Fagaras. And once you can see the Fagaras here. Now Fagaras has 2 children. One is the CBU and another one is the Bucharest. You can see the CBU and the Bucharest, but we will not explore the CBU again because that's already visited. You can see that is already visited. The parent is the CBU. So the only remaining is the Bucharest, and we already reached the goal. That's why the cost is. So finally, the path is this. So very soon we reach the goal. So based on the H value, based on the greedy search, we actually find the path very quickly. And let's see in the real map, what is the value here? So this is basically here, this one. So this is 140 plus 99 plus 211, right? So what is the total value? 0, 5, 450, isn't it? What is the total actual path cost? 140 plus 99 plus 211. You can see here, from here 140, 99, and then this is 211. So the total path cost is 450. But now the thing, is it the optimal path? The answer is no. So can you calculate this one instead? So 140 plus 80 plus 97 and plus 101. What is the total cost? So 8, 1, 4. Even though the number of nodes is higher, I mean the bigger number of nodes, the stations, there was only 3 stations, but there are total 4. But the total path cost is 418. So can you see the difference? So the 450 that was we found by the greedy search, that was very quick, but unfortunately not optimal, because there is an optimal path. So how could you find the optimal path? Just because I know it, and that's why I'm saying it to you. I mean, you don't have to calculate. I mean, just I know it. That's I'm just giving you a proof that the greedy search is not guaranteed to find the optimal solution. I'm saying again, greedy search is very fast, but this is not optimal. And that is the takeaway message of today's class. What is greedy search? The search that we perform using the H value. Is it optimal? No. Is it fast? Yes. And that's all for today. Any question? Any question?
স্যার আগামীকালকে স্যার যে 1 A 1 B এর ল্যাব, দুইটা গ্রুপ স্যার সেম ল্যাবে যে স্যার ল্যাবের টাস্কটা স্যার কি থাকবে স্যার? না আগের ল্যাব থেকে স্যার প্রিপারেশন নিয়ে আসবো কিনা?
Yeah, of course, you have to be prepared with the from the previous class. I will ask you to do some small modifications. Basically, we have to, we have to calculate instead of G, we have to calculate the H value or G plus H value. I mean, some small modifications. But you must come up with the previous assignments that I have already given to you in the last class. Okay, so now you can drop your student ID and name into the chat box of this this Zoom platform. Please drop your student ID and name, and you can leave. This will be considered as an attendance. Drop your student ID and name. I'm saying again, drop your student ID and name. And the CR, Miraz, Miraz,
ইয়েস স্যার।
তুমি একটু কষ্ট করবা, ওই তোমাকে কিছু করা লাগবে না, খালি ওইটা কপি পেস্ট করে আমাকে এখনই পাঠিয়ে দিবা। মানে চ্যাট বক্স থেকে
স্যার
স্টুডেন্ট আইডি
স্ক্রিনশট
আর
নিয়ে
নেম যা আছে, আমি স্ক্রিনশট না, পুরাটা কপি পেস্ট করে, মানে একটা স্ক্রল দিয়ে কপি করে আমাকে পাঠিয়ে দিবা। আমি স্ক্রিপ্ট দিয়ে আইডি বের করে নিব। তোমাকে বের করতে হবে না কে প্রেজেন্ট কে অ্যাবসেন্ট, তুমি
ওকে
জাস্ট ধরে কপি করে আমাকে পাঠিয়ে দিবা।
ওকে স্যার।
তো
স্যার
বুঝতে
আমি
পেরেছো?
স্যার
স্ক্রিনশট না,
আমি স্যার ফোন থেকে
টেক্সট
জয়েন
আকারে
করছি স্যার।
পাঠাবো।
আচ্ছা হচ্ছে স্যার ল্যাপটপ থেকে স্যার জয়েন করতেছি স্যার, ওটা বের করতেছি।
তাহলে কাউকে বলো যে আমাকে পাঠাতে, এটা তোমাকে বললাম, তুমি করো কাজটা।
ওকে ওকে স্যার।
Okay, so class is we are done. Just again drop your student ID and name and you can leave. Thank you very much. So for the attendance, I'm still waiting for 1 more minute and then we'll close the meeting. Close